All right, so let's take a look at another concept, which is relative maximum and relative minimum. Sometimes can be called as the local max or local mean. The plural form of the local max is local maxima or local minima. All together is called as local extrema. So whenever you hear the word local extrema, you know that they actually asking you to find a relative max or relative mean. Or you may have an absolute max or absolute mean. Another way to call is a global max or global mean or global extrema. So how do we gonna determine all these on the graph? The point at which a function changes for it increasing, decreasing, or constant behavior are very useful in determining the relative max and mean. Okay, so let's take a look at this graph. How do we gonna determine at the point of x there's a local max or local mean? Let's first determine the increasing and decreasing interval first. So in this graph, if you notice that the graph can also divide in couple pieces, right? If I draw along the graph from left to right, when I draw my pencil, it looks like I start from this point and I keep dropping to this point. So the graph is decreasing down here on the interval of what? Until what value? Until the x value of negative 2.076. Okay, and after this point, I can draw an increasing arrow until what? Until this value right here, this x value is negative 0.694. And after this value, my graph is keep dropping again. So I can draw the arrow down and then until the x value is 0.52, I will have the curve increase again. So basis on the increasing and decreasing, you can see that when the graph changing from decreasing to increasing, you have the lowest point right there. This is called the local minimum. And if the graph is changing from increasing and down to decreasing, I will have the point called local maximum. So on this graph, I can see there is two of the local minimum because I have two of the point where your graph is decreasing and increasing, decreasing and increasing. So these will be my local minimum. So you can see the local minimum is actually look like a cup, right? You can hold something right here. Okay, so look like a cup. You can hold something right here. That is the local minimum. So my local minimum at the point is negative 0.20, negative 2.076, commas, negative 2.039. And another minimum, local minimum is right here. So it's going to be 0.252 and negative 1.065. So what that mean? That mean at the x equal negative 2.076, my y value is a minimum value, which is negative 2.039. And at the x is equal 0.52, I have another minimum value, which is negative 1.065. And why we call it local? Because these value is just the lowest value between some certain interval around this point, but it's not the lowest of the whole entire graph. So that's why we call local. Okay, and now we have another local max, which is not the highest value among the function, but it's just in the local area. We have that value is the maximum. So that is the one in the green color, which is negative 0.694, commas 1.311. So that is my local max. Now let's do the same thing for the second graph right here. I want to find all the relative extrema and absolute extrema. So this time is also absolute extrema. So relative extrema, so it means I will need to find the local max and local mean. So I'm gonna put some error. So look like if I start from a very left point, I will have an arrow drawing upward, right? Until this point right here, I will have a max. And after that point, I will draw a downward arrow until this point right here. So that will be my mean. And I have an upward until this point, I have my max. And downward, I have mine. All right, so I have three value that two of them look like cap, right? Okay, cap like this. All right, so that is the max. So these two value right here is my max. So I will have a local max at x equal -2 and y equals 16, right? At x equal -2, y equals 16. That is my local max. And my another local max is located at x equal 2 and y equals 16. So 2 and 16. Now my local mean at x equals 0 and y is right on the x-axis, so y gone, so it's equal to 0 because this point is right at the origin. So local mean at 0, 0. Now for the absolute max is the maximum, the highest value for the whole entire graph. So where is the highest value of the whole entire graph? So it looks like these two value is the highest value of the whole entire graph. So we call these two is local max, also the absolute max as well. So the absolute max here will be -2, 16, 2, and 16. How about local absolute mean? Absolute mean. Can I call 0, 0 is an absolute mean? The answer will be no, because at the 0, 0, we still have some other value that's lower than 0, 0. So that value is right here. So I wouldn't be able to call 0, 0 is the absolute mean. But instead, I will have to look at this point right here, where my x is 3 and my y is about 10. -10. So my absolute mean will be 3 and -10. Okay.